For the following questions, we're asked to differentiate the functions, but not to simplify the result. That's so that we can just practice recognizing the functions, when to use which rules, and plugging them in, and not so much about the algebra involved in simplifying them. Okay, so for this first one here, what rule do we need to use? This is one of my basic rules, or do I need to use one of my new rules? In this one, like I said, you see a big fraction there. It should kind of jump out at you. That's going to be the quotient rule. So the quotient rule, we've got the derivative of the first times the second minus the derivative of the second times the first all over the denominator squared. Some people use t and b for top and bottom, but I'm going to use first and second because it'll match my product rule later. Okay, so coming over here, then our derivative, p prime of n, is going to be equal to the derivative of the first. So what's the derivative of 3n? Okay, times the second, so I do nothing to the second, just 11n minus 6, minus, now I need to have the derivative of the second. So the derivative of the denominator times the first, times my numerator, all over the denominator squared. Okay, and again, if I had to simplify, think about distributing, combining like terms, but you would leave the denominator factored out. Okay, for this next example, s of t is equal to the natural log of stuff. So I'm taking the derivative involving a natural logarithm. Remember that we said anytime you're taking the derivative with a log, think about using algebra first to rewrite it and simplify it. So first thing I'm going to do is rewrite this. Since it's raised to an exponent, that can be rewritten as s of t is equal to 5 times the natural log of 9t minus 2. Okay, so that's just algebra, rewriting it. I have not taken the derivative yet. Okay, so now we're getting ready to take the derivative. And again, I'm taking the natural log of stuff. The derivative for the natural logarithm is going to be 1 over u times u prime. So that's one of my chain rules. Another way of writing it is just u prime over u. That's the way I prefer to memorize it. And then my answer is already, usually simplified. So the first thing I'm going to do is, think about my u is 9t minus 2. Okay, so s prime of t will be equal to 5 times, so for the natural log of u, this is going to be 1 over u, so 1 over 9t minus 2, times the derivative of 9t minus 2. You can leave your answer just like that. Like I said, if you had memorized the formula the other way, you would have written it as 9 over 9t minus 2. So either one of those will work. Okay, so for this function here, I do have a fraction, so I could use the quotient rule, in which case, my numerator is 1, my denominator the second one. But I can also use the power rule, the general power rule. So if I take my denominator and I bring it up, I can rewrite this as y equals e to the 3x plus 5x minus 8, that entire quantity raised to the negative 1 power. And then I'm just going to use my general power rule. The other option, like I said, is to use the quotient rule. But the quotient rule is a lot more work. So I'm going to show you it first with the general power rule. All right, so for here, I notice that I have a rational function, and I could use my quotient rule, but this one I could also rewrite it and use my general power rule. And general power rule will be less work than the quotient rule, so that's the route I'm going to go. So my first thing is to rewrite as y equals my denominator, e to the 3x plus 5x minus 8 to the negative 1 power. I can only do this, and it's only going to help me is because my numerator is a constant. So if I have a 1 or a 5 up there in the numerator, this is a nice way to go. If I had an x or 10x, then it would not save me any work by rewriting it this way. Okay, so my general power rule. The general power rule says bring down the exponent, decrease it by 1, and then multiply it by the derivative, multiply it by u prime. Okay, so my u in this case is going to be, whoops, get the green. So my u in this case is going to be, one more time, e to the 3x plus 5x minus 8. Okay, so y prime is equal to, bring down your exponent, negative 1. I'm going to decrease it by 1, so e to the 3x plus 5x minus 8. Now it's to the negative 2 power, and I have to multiply it by u prime. So when I take the derivative of e to the 3x plus 5x minus 8, notice that I have an exponential function in here. And since it's not just e to the x, it's e to the 3x, I'm going to have to use my general exponential rule for that derivative. Okay, so my general exponential rule says it's going to be e to the u times u prime. Or if you want, you can memorize it as u prime e to the u. Okay, so coming back up here, e to the 3x, then that's going to be e to the 3x times the derivative of my exponent, so times 3. And then the derivative of 5x is 5, and then minus 8 is a 0. So this is what my final answer would look like if I'm not simplifying it. Okay, so for number 4, I have the natural log of this big fraction. So when you look at this, you may see the fraction first and think quotient rule, but the main function, or the outer function, primary function, is natural log. So I'm taking the natural log of stuff. So this is going to be my general natural log rule. But before I get to that, same thing we did earlier is I'm going to say, well, let me use algebra first to rewrite this. So when I have a logarithm of a quotient, I can go ahead and subtract them. So this is going to be the natural log of the numerator, so the natural log of 15 plus x to the 4th, minus the natural log of the denominator, 2x minus 11. Okay, now I'm going to go ahead and use my general logarithm for both parts of it. Okay, so reminder of my natural log rule, it's going to be 1 over u times u prime. So in this first one, my u is 15 plus x to the 4th. So g prime of x is equal to 1 over u, so 1 over 15 plus x to the 4th, times, what's the derivative of u? 4x cubed. Same thing for the second part. So I'm going to have 1 over 2x minus 11 times the derivative of my u. So the derivative is going to be 2. And that's what my unsimplified answer could look like. And again, I just want to kind of say that another way of remembering the log rule is to just say u prime over u, in which case you would have gone straight to, we would have said the derivative of u, so 4x to the 3rd, over u, 15 plus x to the 4th, minus, and then the second one, the derivative of u, so the derivative of 2x minus 11 is 2, all over u, so 2x minus 11. Like I said, this is just a little, I think, more compact, looks a little nicer, and then it's already simplified. But the choice is yours. Okay, so for number 5, I've got a radical here. We learned back, even last chapter, when you see a radical, convert it to, exponent notation. So I'm going to rewrite this as m of t is equal to t plus 6 e to the t squared plus 1. Since all that's underneath the radical, all that is raised to the 1/2 power. So now I'm looking at this and I'm thinking I have, u to the 1/2. This is going to be my general power rule. Okay, so m prime of t. I bring down my exponent, 1/2. I decrease my exponent by 1. I'm not taking the derivative yet. And then I am subtracting 1 from my exponent, so 1/2 minus 1 is a negative 1/2. And now times whatever u prime is. So notice again that here I have, so it should be squared, I have e raised to some power, so we're going to be using our general exponential rule for this piece of it. So taking the derivative of my u, the derivative of t is 1, plus 6 times, now when I take the derivative of e to the t squared plus 1, I get e to the t squared plus 1 times the derivative of my exponent, so times 2t. And there's my answer, again, not simplified. So question number 6, I've got this fraction, so there's no way to rewrite it that would be helpful. I mean, I could bring the denominator, bring it up and raise it to the -1 power, but then I'd have to be using the product rule along with the general power rule. So it's actually better to leave it written as it is and just use the quotient rule once. Okay, so y prime is equal to the derivative of the first. So what's the derivative of my numerator? So it's going to be 10 e to the x. And here I didn't have to use my rule because it's just e to the x. Again, if it were e to the x squared or x plus 5, then I'd have to use my general exponential rule. So the derivative of the first times the second, so times x squared plus 1, minus the derivative of the second, so the derivative of the denominator is 2x, and then times the first, so times the numerator, 10 e to the x minus 3. All of this over x squared plus 1, that quantity squared. Okay. Just a note about parentheses. I don't need to have the parentheses. These right here around the 10 e to the x because it's a single term. But it is necessary to have the parentheses around the x squared plus 1, and then also later on over here the 10 e to the x minus 3. All right, so for number 7, I have a bunch of stuff raised to the 4th power. So that's going to be my general power rule. Again, when you're using your general power rule, think of, all this in here is my u. That's what's being raised to the 4th power. So q prime of t is going to be equal to, we bring down our exponent, the 4, then we decrease it by 1, so we have 6t to the 5th minus 8t cubed minus 21 is raised to the 3rd power, and now times the derivative of u, so times the derivative of 6t to the 5th minus 8t cubed minus 21. So we get 30t to the 4th minus 24t squared. And there's my unsimplified answer. Okay, so for number 8, I have a fraction. And I may want to think about dividing each term by x, because sometimes, especially last chapter, we would simplify the function first and then just use our basic rules to take the derivatives. The problem is here, if you look at this last term, I would have the natural log of x over x. I'm stuck using the quotient rule either way, so there's no point in rewriting this. I'm going to leave it as it is and just jump right into the quotient rule. Okay, so c bar prime of x is going to be equal to, I need the derivative of the first, so the derivative of my numerator. So I get 0 plus 200 minus 200 times, and then the derivative of the natural log of x will be 1 over x. So that's the derivative of the first times the second, so times x, minus, now I need the derivative of the second, so the derivative of the denominator is 1, times the first, so times my numerator. So I have 1,000 plus 200x minus 200 natural log of x. And all of this over my denominator squared. And there's my answer, not simplified. Okay, so here I have the square root of stuff. So like we said, anytime we see the square root, we're automatically thinking, go ahead and rewrite it to the 1/2 power. So h of x is equal to all of this to the 1/2 power. And since I have a bunch of stuff raised to the power, I know I'm going to be using my general power rule. So while I'm using my general power rule, again, all of this is going to be u. So when I have to take the derivative of u, I'm going to have to use the quotient rule. All right, so this one's going to get a little messy, but like I said, we don't have to simplify it, so that's okay. So taking my derivative, again, my main function is not the fraction, it's the 1/2 power, so it's the power rule. So h prime of x is equal to, I bring down my exponent, I'm going to decrease my exponent by 1. So everything inside stays the same for the moment. So this is the -1/2 power. Now times, the derivative of u. So I have to use my my quotient rule for that. So my quotient rule, I have the derivative of the first, that'll be 10x, times the second, so times 3x minus 7, minus the derivative of the second, 3, times the first, so times 5x squared plus 3 all over my denominator squared. So over 3x minus 7 squared. So there you go. All of this, that whole thing, this is my answer, not simplified. Okay, so let's look at number 10. I've got 2x to the 5th times 8x plus 5 raised to the 3rd. I'm actually going to have to use my product rule. Main thing is that this is a product. I've got 2x to the 5th times 8x plus 5 to the 3rd. So product rule. And then while I'm using my product rule, I'm going to have to also use my general power rule. Okay, so I'm actually going to go ahead and color coordinates here. So the first is going to be 2x to the 5th, and then my second will be the 8x plus 5 to the 3rd power. So product rule says the derivative of the first, so I'm going to take the derivative of 2x to the 5th, so I get 10x to the 4th, then times the second, times 8x plus 5 to the 3rd power. And now this will be plus, I need the derivative of the second. So when I take the derivative of the second, this is going to require my general power rule. Okay, so taking the derivative of 8x plus 5 to the 3rd, we bring down our exponent. We will decrease our exponent by 1, and then multiply it by the derivative of what's inside. So times 8. So that's my derivative of the second, and then we still have to multiply it by the first. So times 2x to the 5th. All right, and there's my answer, not simplified. And just a note about simplifying something like this, you'd want to clean up your coefficients on the second part first. So like the 3, the 8, the 2x to the 5th. And then you would go ahead and look for common factors to take out. And one of your common factors would be the quantity, 8x plus 5 squared. So it gets a little messy. But again, we're going to go ahead and leave it as is. Okay, this last question, and there will be nothing that looks anything like this on the test. I like it. I think it's a fun problem, and it can show you how logarithms can be useful. So when you look at this right now, I would have to, if I want to take the derivative, I've got a quotient, and then inside the numerator, I've got a product, and then between the numerator and the denominator, I have 3 power rules. So this thing would be a huge ugly mess if we just try to use the rules, the general, if we use the quotient rule, the product rule, and then the general power rule several times. So we're going to use something called logarithmic differentiation. So what I do is I take the log of both sides. So I'm going to take the natural log of f of x, and that has to be equal to the natural log of all of this over here on the right hand side. And we can do that because logarithms are one-to-one functions. Okay, so got all that written down. Now, what is, the right-hand side? The reason this helps me is because with logarithms, remember, if you have a product, you can write it as the sum. If you have a quotient, you can write it as the difference. And then exponents even come down as coefficients. So for right now, I'm leaving the left-hand side alone. So I've got the natural log of f of x is equal to. So then over here on the right, like I said, this is going to be the natural log of 14x squared plus 5x to the 5th power plus the natural log of 2x minus 5 to the 3rd power minus the natural log of 7 minus 4x to the 10th. I'm going to take one more step and bring those exponents down. So this becomes 5 times the natural log of 14x squared plus 5x plus 3 times the natural log of 2x minus 5. And then the last one, minus 10 times the log of 7 minus 4x. Okay, now I'm going to take the derivative of both sides of this equation. So when I take the derivative on the left-hand side, so the derivative of the natural log of f of x is just going to be f prime of x over f of x. And then over here on the right, I'm going to take the derivative of each term. So the first one I get 5 times. And then remember what we had for our general log rule. So it's going to be the derivative of u over u. So this becomes 28x plus 5 all over 14x squared plus 5x. Same thing for the next two terms. So I got 3 times. So the derivative of the natural log of 2x minus 5. So go ahead and dig green. So I got the 2x minus 5, that's going to be the derivative of u, so 2 over u, 2x minus 5. And then my last one, here my u is a 7 minus 4x. So we get 10 times, I'm going to have u prime, negative 4 over u, 7 minus 4x. Now I'm not done, but I've got one more step. Remember, what I'm trying to do is get f of x alone, f prime of x alone. So multiplying both sides by f of x will give me f prime of x. So what I do is, like I said, I multiply both sides by f of x, so these two will cancel. So I got to multiply all of this by my original f of x. Okay, I'm running a space here, so we're going to finish this off. F prime of x then is equal to all of this here. Again, you can, if you want to simplify the coefficients, I'm going to leave it exactly as it is. So 5 times 28x plus 5 over 14x squared plus 5. Then plus 3 times 2 over 2x minus 5 minus 10 times negative 4 over 7 minus 4x. And then all of that times my original f of x. So times my original f of x over here. So I have 14x squared plus 5x to the 5th power times 2x minus 9 to the 3rd power over 7 minus 4x to the 10th power. And that is the derivative. Thank you very much.